helps a lot, I think. So Kjeld from QConsult has prepared a getting started session with with Minitab. He basically we worked on the preparation a lot together, and my input was that we use an example that is immediately applicable for you guys next week. So everything that Kjeld will show you is basically a competence that that we will apply next week. For Kjeld, who will start the presentation in let's say 2 minutes. For him, it would be great if it's okay for you to switch on your camera, that he doesn't have to present like into a black hole. If you're on a place where that's not useful, or you don't want to do it, also fine. But if you want to do it, I think we help Kjeld a lot with that. Thanks for the people who already do that. Thanks a lot. Hey, what Kjeld will do is he will demonstrate the application from our case, as I just discussed. He will demonstrate that. If you have questions, would be great to just throw them in. Don't keep them for the end, because we don't know how fast or slow we will go through everything. So just throw in your questions that we make it a interactive session as best as possible. If you don't want to say it with your microphone, it's also okay to type it into the chat, and I will read the chat and sometimes maybe point Kjeld to extra points. Obviously, with microphone is obviously the best way to get a good interaction. I think that's enough for me, if you're okay with it. So maybe one last thing. So what Kjeld will do is give you a good demonstration of the case that he prepared. And in the end, he will present, let's say, a sort of a mini homework assignment. And that is basically that you do roughly the same that he did, but then a little bit smarter. So you can maybe make some notes for the important points that Kjeld shows, that if you do it yourself, that you know the rough layout of the steps to take. Obviously, it helps to see Kjeld demonstrate this, but as we all know, it helps a lot more when you do it yourself, and then all the stuff that looked extremely easy when Kjeld did it might prove to be a little bit more difficult when you do it yourselves. Yeah. But the homework that we have is not planned to take more than an hour of your time. So it's let's say a mini assignment, and hopefully useful for next week and useful for your learning process. Okay, that's it for me. Over to Kjeld. Thanks.
Thank you. So I'm Kjeld Stammels from QConsult Progress Partners. I give mostly the Six Sigma trainings for QConsult, so I use Minitab quite often. But to understand Minitab, we also need to dive a little bit into statistics, so we'll try to do that today also. I will also be present next Monday, so for any questions that we can't answer in this session, you can ask me in person on next Monday. Good, that's okay. So first let's start at take a look at the learning objectives for today. So we are going to look at Minitab basics, the understanding of the advantages of Minitab, so why Minitab might be more easy to use sometimes than Excel, also how to get data from Excel into Minitab, understanding basic charts in Minitab, and a little bit of a shadow dive into regression, zowel linear as well as quadratic with the confidence intervals. So first I will show you how Minitab looks. So if you take a look at Minitab, it's divided in two spaces. So the below part just looks like Excel with columns and rows, and the gray area underneath C1 or C2 are there for headings. If you fill in numbers, it will automatically understand that those are numbers. if you fill in dates, it will automatically understand that you are talking about a date. And if you fill in text, it will automatically understand that you use text. So I just demonstrated here. Why that's important is because maybe you type in a number with a comma or a dot, comma or a point, then it will automatically see that it's not numeric. That might be helpful if you have the wrong settings from Minitab when you transpose data. Now we will mostly look at statistics in Minitab as well as graphs. So you will find that on the top left of your screen. So this is the basic understanding. So it has columns, and every question you ask Minitab, it will spit out in the so-called session window. That's the gray area. You will see it in a minute how that looks when you give it a question. Let me try. Okay, so the session window, the output of the tools that you ask, and the data where you can transfer data from Excel into Minitab. And what I just showed you, numeric, text, and dates, it will automatically understand what you are using. So we are, as Mark just described, we are going to use a case which is familiar for you guys, to say the least. So we have a digital catapult, and we want to know what release angle or how far back should we pull the catapult to shoot a desired distance. How mathematicians write down the same thing is a little bit different. They will use a regression model, you see here, to get a transfer function. And a transfer function is y is a function of x or more xn, more variables. And in this case, we will look at y variable as distance and the x variable as release angle. The slides are already on your Teams space, so you can reach the catapult directly from the slides.
I already put the catapult now in the chat also as a...
Don't try to look at it right now, because then you might not see what I'm doing on my screen.
Handje.
Handje, yes. You can just ask questions. If there is anything you want to say, you can turn on your mic and ask a question. Or however, if you rather type it in the chat, that's also possible. Was there a question?
I think Stefan had a question, but I think it is already answered because the hand is dropped. Correct,
Yeah, correct.
Stefan? Probably.
Yeah. Okay, then I will move on. So just to take a look at the catapult, it's a digital one. So the farther back the more I increase the release angle, it further away it shoots, the more distance we get. And if I have a smaller release angle, it will shoot less far. But we want to know, what is that relation? So how does that correlate with each other? And we're going to dive deeper into that one. So first, the main question we want to answer is, what release angle should we use if we want to realize a desired distance? And to answer that question, firstly, we are going to dive deeper into a so-called experiment. And this experiment, what distance do we get if we use a certain release angle and we keep it constant, so we don't change it? So for example, we set the release angle at 110. What distance do we measure? And we repeat it, say 10 times. I'm going to show you how that is done via a way that you all know or are at least familiar with. So if you take a look at the catapult again, I'm just going to shoot 3 times. So if I pull back at that 110, it shoots a certain distance of 90. I'm just going to notate that in Excel. So release angle as our x variable and distance as our y variable. So if we look at 110, we get a distance of 90. Let's try it one more time. If you pull back, do we get the same distance? The answer is no. We get a distance of 86. 86, yes. And one more time to try to understand the catapult. We shoot again 91, so it's more. So there is some type of variation while we do keep the release angle constant. So that's interesting to know. Here I did it 10 times or 15 times. I already did it, so I'm not going to show you. I hope you will understand how to use the catapult. I'm maybe going to pause this video just for 1 second. I will going to show you the online web application of Minitab, because for some people it's more easy to use that the web application than the desktop version, but I will show you both. How they work are exactly the same, it just has a different feel and look. So if you have the data from the release angle and the distance, we can just copy and paste it in Minitab. This is the wrong Minitab, this is the desktop version. I will first show the Minitab version, the web application. So if we open Minitab, it takes some time to load. You can just copy and paste the observations or the experiment in there. It is important that you paste, if your data has headings, that you paste it in the gray area below. So you have room for all the observations below. Just as you saw previously in the web version, or in the desktop version, the output session, output window and the session window and the columns are the same. And the headings upstairs also are the same. So we're not going to dive into data, but statistics is interesting. And first, let's make a histogram. And a histogram, I'm going to talk a little bit more what that means and how it works. So the Y variable was distance. If I select that option and click on options, you can see that you can choose some extra options that you might want to fit. So let's try to fit a normal distribution through this graph. So the output window gives what we just asked Minitab, it will show in that session window. I'm going to talk a little bit more about histograms and variation in general. And to understand variation and histograms, maybe a question for you guys. What does a histogram do? Does anybody know it already? What it shows? No? Okay, then I'm just going to show. Let's take a look at this video. This is called a Galton board. And what it does, it has balls on the top and it drops them and it gives a certain distribution. So let's try it again. And it will give some different results, but it follows the same distribution. It's slow motion. Did not see that previously. So what you see here is, I'm going to pause it. The more in the center, the more balls drop in that particular spot. And the more that we move through the sides, less balls are going to be counted there. So the variation is small right in the middle and spreads out at the bottom. What is a histogram? A histogram is, we are just going to count how often something does occur. So for example, if we take a look at one size, we're just going to count how many times did that happen. How that looks in Minitab from our experiment is like this. So we see that the distance of 85, we have shot that distance around 3 times. So just counting how often did something happen. If you have a lot of different experiments and a lot of data points, a histogram following a normal distribution will most likely go to look like this, as you just saw with the Galton board. Now let's dive back into our case. If there are any questions, feel free to just ask them. What's also interesting is how much variation did we have in our experiment. So I already showed that text is automatically recognized. Yes, thanks. So we have a histogram. Now let's try to make a box plot of the same data. So if we're going back to graphs and we're going to box plot, it's below. We are going to generate one because we have one variable. It's simple, we don't have any categories, so we can use the simple version. The y variable is still distance, that is what we want to measure, and I'm always going to choose the median and the mean symbol. Then it spits it out in the output session right here, and I'm going to show you a little bit more of a background on box plots. So a box plot, so my mouse is not working correctly. It's a bit, let's try this one. Okay, so a box plot shows the variation that you get given a certain experiment that you did. So it's the same 15 measurements that we did previously. And what it captures, this line we see here, captures 25% of all observations. The next 25% of observations are captured between those lines, and the next 25 above, and the next 25 in this one. So it's the broader the distribution, the longer this graph will look like. And you can see that it looks a bit symmetric. So the lower part looks nearly identical to the top part, and that means that it is a normal distribution. So you could draw, if I'm a great drawer, some type of normal distribution there. Not quite, but not the best drawer in the world. If you hover your mouse in Minitab above the box plot, it will give you some more information. Most likely the Q1, which means what's in the quarter 1, just the lower 25%, where is that line? And that's 82. So we look here, we can see that that's around the 82 mark. It will also show you the total range. So what's the lowest observation and the highest? So 75 and 98. But it will show you what's the variation and how much are laying around the center. I'm not going to dive deeper into the median and the mean, because that's most likely the same for a normal distribution.
So what's for us interesting, if we make a box plot from the data of the catapult of you guys, the total range that we see there is a good indication basically for our quality class. What we should not do is just take the max and the minimum value to say what our quality class should be, because we only did 15 experiments. So from this board that Kjeld showed, we only have now 15 observations. So if we do not 15, but in the production run we have like 50. So then these tails will be longer, obviously. And then this box plot is a better indication of the total width that we expect than just subtracting the minimum from the maximum value, basically. That's the most important thing, why Kjeld now shows how you can draw a histogram and how you can draw a box plot.
Yes, that's correct. I'm not going to use my mouse anymore. I think something went wrong with those slides. So I'm going back to the case once more. Let's take a look at the case further. So how can we define the influence of release angle on distance using experiments? So lastly we tried only one release angle, namely 110, and we did it 15 times. But we also want to know what happens if we use different release angles, and what if we can repeat those release angles numerous times. because then we can make box plots of every release angle. What will happen with the variation over a longer distance? So let's try a new experiment. So 6 different release angles. What happens when we repeat every angle 5 times? And what is the measured distance? Now, mathematicians have a funny way of writing that down. So the experimental setup will be, we have the x variable release angle, and we're going to set it at 110, 120, 130, 140, 150, and 185. Why those? Because that is the minimum and the maximum setting. How often are we going to repeat the same release angle? That's denoted by the n, and the total n is 30. Namely, 5 times 6 is 30. I'm going to show you how that's done. So I already did the data gathering from the catapult, and you can see that we have around 30 measurements. I'm going to copy and paste it, but now in the Minitab desktop version. So let's make a new worksheet, paste the headings in the gray area. So we have C1 and C2, 110, 120, and all 5 measurements. So this is a new experiment and might give us more information on how to answer the question, given a desired release angle, what should we use? Now first let's make a scatter plot of the y variable distance, because that is what we want to measure, and the release angle as our x variable. I'm not going to change any settings in here, and it will spit out the scatter plot. Are there any questions so far? No? Just going to move on then. Scatter plot is interesting because then we are going from the scatter plot through correlation and then on to regression. A scatter plot is nothing more than the x variable on the lower side and the y variable on the y-axis, and we're just going to denotate what did we measure. So 110 we measured around 100. 185 we measured also 5 points, and what did we get as a distance in y?
So these are 30 blue dots,
Yes.
right? A lot of them are on top of each other.
Yeah, so exactly. Is there anything interesting that you can see based on this graph? I see some nodding from certain people. Are you also confident enough to share what you see?
How farther we shoot, how more the dots go out of each other.
Yeah, exactly. So that is the first thing that shows up. So the further we shoot, the more variation we get. So the dots are further away. I'm just using some terminology that is broadly used in statistics. So variation. But correct.
It also seems to follow a line.
It's also, yeah, of course, also a line. So if you draw a straight line, I'm not going to draw anymore, but if you draw a straight line, it will look like it's going to follow even further. Okay. That's correlation. Scatter plot. Now on to correlation. And correlation uses the exact same graph as the scatter plot. So this is just the same as we saw previously. But it will give us a correlation coefficient, and that's called R. And what that means, how much does one variable correlate with one other? So if I go up in distance, what happens to up in release angle? What happens to distance? That's a question for you guys. It also goes up. So the more I increase release angle, the more distance that I get. Correct? Now, the correlation coefficient will always fall between 0, -1, and +1. Where 0 is weird 0. No correlation. -1 is a strong negative correlation. So the
more release angle, the less distance.
yeah, it's not in this case, but in this case it's the positive. So the more release angle, the higher or the further distance we get. And now on to regression. So this is a scatter plot once again. So we have a y-axis and an x-axis, and we are just going to plot each measurement that we did based on what x, what is the measured y that we get. Do you think there's correlation in this graph? Yes, positive or negative? It's positive. Yes, positive. So there's a positive correlation. And what does regression do? Regression tries to plot the best fitting line through all of those points. And the best fitting line means the distance from each individual point has the least distance to the line. That's regression. But why do we want to use regression? We want to use regression to give answer on the question to explain or predict if we use a certain x, what y variable do we get? Or the inverse, if we want to shoot a certain distance, what x variable should we choose? Dus if we want to shoot 300 meters, centimeters, what release angle should we use? That's what regression tries to do. And why that's important? Because we don't have a lot of measurements in this part. But by drawing a line through those plots, we can predict where most likely the outcome will fall. That's a basic part of regression. In statistics, we are never really sure about anything. So we draw confidence lines. And that means this line will most likely fall with 95% confidence between those lines, between the red lines. So for example, if we did the same experiment, what will happen with, so we are going to just discard all the measurements that we did previously. We are going to do a new experiment, get a new data, look at the observations, then the line might be changing a little bit. But where between those lines will it then lay? So statistics says with 95% confidence or 99% confidence, that's the most used statistic, it will fall between the red lines. So it also could be moving a little bit more shallow or steep. I'm going to show you here what does Minitab show you when you ask to make it a regression. It's a different example, so don't try to look at data points exactly, but it is a nice graph to explain what is happening. If you take a look, we see the red line and the black line. The blue lines we can just discard, we don't use them. The black line is the regression lines, so it predicts or explains the relationship between x and y. The red line is the confidence interval, so the interval in which the regression line will most likely fall, with a certain confidence. It will also give you a function. So you see here, male sales minus 74 points plus a certain number times the man ability test. So it will give you the formula, and the formula is, we want to have a formula because then we can solve it via mathematics. How should we, what release angle should we use if we want to shoot a certain distance? And it also gives you the R squared, and that means how well does this model explain, or in other words, the relationship of x explains the outcome in y. So in this case, I'm going to pronounce it correctly. So the variation in x, or release angle, explains with 93% the variation in distance. 93% is a very high number for an r squared. Most real life cases, 70% of r squared is high enough to have an accurate or a predictable model. Useful model. So 93% is extremely high. Let's dive a bit more in the r squared. So it means the variation in y is explained or predicted by the variation in x. So for example, if we get an r squared of 70% and y is the distance and x is release angle, we can say 70% of the variation in distance is explained or predicted by the variation in release angle. That means that there is still 30% of variation that is not described by the variation in release angle, or is not captured in our model.
Clear.
Now back to the case. So why do we want to know this? If you click on regression and choose the fitted line plot, you can see that it gives you the option to choose a y and an x variable, so the distance and the release angle, and what type of regression model we want to use. We are going to explain it with the linear model and the quadratic model. So let's first choose the linear. I'm going to display the confidence interval with 99% confidence. And it spits out an r squared of 98.77, certain p-value, but you can discard that. And it gives you the chart that we saw previously. I'm just going to make it a bit bigger so that you can see what happens exactly. So it plots distance based on release angle. It gives you the blue lines or the green lines as a confidence interval, and the red line is here the regression. It's red, right? Yeah.
Yep.
So I just pasted it in PowerPoint. It gives you the function, and that's easy because then we can solve if we want to shoot a certain distance. So for example, if we want to shoot, let's say 250 meters. Centimeters. Sorry, I'm still confused with that. Centimeters. That means that we transpose this 415 to the other side. So 250 plus 480 divided by 4.802. And that gives us what release angle should we use if we want to shoot a desired distance of 250 meters. Centimeters, mate. It also gives you the r squared and the plot, so the graph. And that means that it also denotes the function and the r squared again. So it's a summary of everything that did happen. If you take a look at this graph, is there anything particular that stands out?
Quite a few dots actually outside of the green dashed line.
Yeah, so quite a few dots are outside of the line. Yes. Anything else if we take a closer look based on those dots? Do you think this is linear? No?
Maybe not, huh?
Maybe not. And why we see that is based on those points are below, these points are above the line, and all those 5 points are below it. So it more looks like a line that will look something like this, with a small curvature at the end. Correct?
Maybe, yeah?
Maybe.
Let's try.
Now, why it's important that we ask questions based on what Minitab gives us, because if we look at the r squared, we get an r squared of 98.8%. And I told you, if it's higher than 70, we are extremely happy and it's a useful model. But we want to understand what we want to understand the output that Minitab gives us, and ask us questions. Can we explain why it has a particular look, feeling? Why does it give us this output? So, for example, if we are going to change the model into I'm going to linear model, quadratic. I'm going to show you the quadratic model. You see that the R squared improves significantly. So it goes to 99.9%. So that's nearly 100% of the variation in release angle predicts the variation in distance based on this model. In other words, we just reverse engineered the formula that the catapult uses.
The online catapult obviously is not a physical model, right? So this online catapult that you play with, they just programmed functions behind it. And what Kjeld just did is basically reverse it, engineer it. So if you, for the physical catapults that we're using in the training, don't get values like the 98 or even 99 that we see here, that's absolutely to be expected.
Yeah.
So now we know exactly which type of function they used for that online model, basically.
And it's small quadratic, based on this part here, and you see that the points are better fitted on the line right here than on this graph. So that's why we want to ask questions. Can I explain what I am seeing currently as an output from Minitab? So the R squared improves, and we look at the graph and we see a more nice curvature and better fitted line between all those points. So now we have the regression. But now what? What should we do with this information? Because we understand the distance, the release angle, we have a formula that we can use. So there are a few ways that we can, no, let's start again. We want to shoot a desired distance of 250 meters. Centimeters. Why that's important is because that's the furthest that we are going to shoot in our real life example.
Exactly. So the customer, like in the previous module, asked us to launch products over 1 meter and maximum 2.5. Sorry, now I'm also 1 meter to 2.5 meters. Yeah. And what we just also saw for this online model is that variation increases with the distance shot. So if we now want to find out what quality class we could realize with this online model, we want to solve this for 2.5 meters. If we can define what release angle we need for 2.5 meters, then we know how to reach that, and then we can maybe do experiments to find out the quality class that we are able to realize for the 2.5 meters.
So we can solve it mathematically. We can ask Minitab to do it for us, but the easiest one is just to read from the graph. So for example, if we want to shoot 250 centimeters, we just draw a line from 250 to the regression line. And then we are going to look below it. So between 130 and 140, and if you use Minitab, you get a variable, or the release angle should be 136 to get a desired distance of 250. But what we also saw was that the further we shoot, the more spread in our distance we get. So the more variation it's introduced. So let's try to do a new experiment based on this example. So we want to shoot 250, we get a release angle of 136. Let's try to shoot 16 times with a release angle of 136. Why we use 16 instead of 5 is because we want to understand the variation better, and more data points are always better to understand the variation. Because if I shoot only one time, I can't define any variation. If I shoot 2 times, a little bit, but if I shoot at least 15 times, or 30, but 15 is great for your cases, then we get a little bit more confident about the variation.
That's a sort of rule of thumb for the statistics guys, that if you want to have an idea about the average, you do roughly, let's say, 3 or 6 experiments. That's just a rule of thumb. And if you want to have an idea about the variation, you do more. And then a logical value that statistics people use is maybe 16. You can just use those values
for your during your course days. So let's write that down. So we know the 250 that we want to realize. We have a 136, so that's mathematical solving of the formula. And let's try a new experimental setup with 16 times repeat the same release angle. These are the answers. Of course, we are going to try and use Minitab to give us more information about those numbers.
So what just happened is that Kjeld and me, we already did that for you guys, okay? So these values are from that online model. So release angle 136, and then we did it 16 times, and then you get these distances.
These distances, yes. So a little bit of background on statistics. And if we have a normal distribution, that means that between -1 standard deviation and +1 standard deviation, 68% of all observations will fall between -1 and +1 standard deviation. Standard deviation is a maybe a hard to understand figure or statistics, but what does it mean? It means the average average deviation from the mean, from the average. So we count up all the deviations from the observations and the mean, and what is the average deviation from that? 95% will fall between -2 and +2, and -3 and +3 standard deviations, 99.7% will fall between those lines. That's a known statistic, a given fact.
If I may just take a second for you guys, so this standard deviation, if you give Minitab the results of your experiments, Minitab will calculate for you this standard deviation.
Yeah.
And if we now would use this standard deviation to calculate the size of the box that we want, and we would use 1 time the standard deviation, so maybe you can point it on your so -1 to +1, then only 68% of our launched products will fall into our box. 15% will be shoot too wide, 15% too low. 16% to be exact. Yeah. So only when we use 1 sigma, then only 68% of our launches will be inside the quality class that we defined.
Yeah.
So we shouldn't do that. We should use a bigger box, right?
And we're going to learn you how to get the standard deviation from Minitab, so you don't have to calculate it yourselves, but Minitab just gives it to you if you click on the right buttons. So I uploaded all the data in this data set. You can see that we have 16 different measurements. So if you go to basic statistics and display descriptive statistics, you can fill in the y variable that you want to measure. So that's the distance, and you can select a lot of different statistics. For you guys, the standard deviation is the most important to look at. Standard deviation, mean is the average, and I always choose the range, so the minimum and the maximum, just to give me some example of what is the range that we observed with this experiment. But standard deviation is the most important one for this example. So we select all of the statistics that we want to use, the range, minimum, maximum, and if we click on OK, and again on OK, it will give you the distance, how many times did we repeat this experiment, so n, 16, the mean, so what was the average of all the data that we measured, what was the standard deviation, ST-DEV, standard deviation of 2.45. So then we can calculate what should the box be, so what should our quality class be based on this number. So if you take a look at the output, I just pasted in PowerPoint, we can use 250 as our mean that we want to shoot, and we are just going to subtract multiple times the 2.45. I'm going to show you how we are going to do that. So I tried to draw a normal distribution. It did not go very well. Let's say 2.5 meters, plus 1, plus 2, and plus 3 sigma, and the minus 3 sigma, and this whole part should be our box. And why that is because 99.7% of values will fall between minus 3 and plus 3 sigma. So if you're going to shoot 100 times, then 99.7% will be correct. That gives us also a part per million. That's a standard given statistic. So if we are going to shoot 1,000,000 times, that means that we are going to miss around 2,700 times. Now for your experiment or for your final simulation, all the factories together will launch just over 1,000 products. So to beat Fontis, I thought you need to shoot less.
So they missed a lot more shots than 3. All the factories together, a lot more. So if we would use for the calculation of your quality class, we would use 3 sigma. Then we expect in your final simulation next week Thursday that only 3 products will miss the box, which would actually be a fantastic result.
Yeah. So what I did here is just calculated the 250 plus 1 plus minus the 2.45. So the better you set up your catapult, the smaller the standard deviation will be. So you give the same, use the same rule of thumb, so minus 3 and plus 3. But if you have a better setup catapult, the quality class can be smaller. Obviously. But the more less failures we will get. So if everyone chooses those rule of thumb, plus 3 and minus 3 standard deviations, we will not shoot more than 3 times miss our target.
As long as we don't get nervous during the production run and do things differently than in our experiments, and obviously that's a really important factor for real life, but just from a mathematics standpoint, if our experiments are representative for what we will do in the production run, then all this is, let's say, 100% correct.
Yeah. So what I did here is, I'm clicking too fast. Minus 7.35 are just 3 times 2.45, the same as here. So if I apply those rules to your quality levels, you can see here the quality classes that you use during your course. This is in centimeters, so that means that we can choose a quality class based on those numbers. And if we take a look at how that looks, it means that A4, we can't choose A4 because then we still will miss more than 3 in 1,000 experiments. So we need to choose a class higher, A3.
For the wooden catapult, this is the online model. This is not your data, right?
So this is the experiment that we, or the case that we try to explain to you guys. So how to use Minitab to get a transfer function, so to understand the relationship between two variables, and to use statistics, so -3 and +3 sigma, to give you guys a quality class. That is what we tried to do. And this is the homework exercise that Mark just talked about at the beginning. We want you guys to try to beat my quality class of A3. And how you can do that? The catapult has more different variables.
Maybe you can show that, and it's easier to define. If you want, I can say a couple of words about that.
Okay.
So if Kjeld opens the catapult the online catapult model.
Scherm. I'm going to share my screen. So I have always Minitab open. Not really. You use it in the chat. So this one. It's also in the slides. So if you click on this link, you will get the virtual catapult right here.
So what Kjeld did for all the experiments that he just showed you is that he only played around with the release angle. But obviously you can also change your elastic band settings. You can also change the position where it is where it is attached on the arm. You can also change the stopper angle. So you can change a lot of stuff on this catapult. All those settings Kjeld didn't touch. So he used only the settings as default, only change release angle. So what would be a great experiment for you guys if you want to get a little bit of experience using Minitab is change one other thing. For example, Kjeld, what could they do?
If you
maybe use a little bit different stopper angle. So just change your stopper angle to one value, every time the same. Just choose another stopper angle, and then what you could do is repeat the whole exercise that Kjeld just showed you. So first determine your transfer function, use the transfer function to look up the release angle to shoot 2.5 meters, then use that release angle together with your stopper angle to shoot 16 times to get a sigma, and find out your quality class. And because Kjeld did everything just as the default settings of the catapult, you might very well be able to beat Kjeld's quality class. So that might also be an interesting bet if you're able to find a setting on this catapult to go better than the quality class that Kjeld just showed. And he promised a small incentive.
So beer and a wireless charger. So I sent an email to everybody. So maybe some of you have already read the email. I also described the step-by-step guide on how to do it yourselves. So where to find it in Minitab, where to look. So if we talk about use our experiments, the first experiment that we did was just to get a hang of Minitab and the basics. So you should look at I'm just going to show it here, after this one.
Experiment for the transfer function.
Yeah, so the experiment for the transfer function, choose your axis, at least 6 different release angles or more if you want, but 6 should be fine. Repeat it a numerous of times. Get that transfer function, look in the graph where what release angle should I use to get 250 meters? Centimeters. Repeat that more than 16 times, or at least 16 times. Get the standard deviation based on descriptive statistics. Just use stat basic display descriptive statistics. Can you see my screen fully?
Yes, fully.
Click on statistics and look at this number. If you click on OK, it will give you a standard deviation. So this is quite much, because I don't know why it's that much. Now, choose that standard deviation, multiply it 3 times, and that should give an indication on what quality level or quality class you could choose.
Okay.
I'm going to.
This sounds doable, I think, and obviously the success is not the thing that's important, right? So it might be great just to get you guys play around in Minitab a little bit. If you're not able to get to any other quality class, or not able to define even your quality class, that's also not a problem. Kjeld will be there next week, and you can just show him your progress. This exercise is mainly meant to give you something useful to do in Minitab. Maybe you do the online experiment, get stuff in Excel, copy paste it to Minitab as Kjeld showed, try a couple of graphs. If you're able to beat his quality class with this online catapult, obviously that would also be a fantastic result, right? But then we're a little bit ahead of, let's say, a green belt level. If you guys want a question on black belt level, if you could show again the online catapult.
Let's open again the catapult. This one, I know you can't see my screen yet, so I will share my screen in a moment. Maybe mute.
Yeah. So what we just discussed, right? So we always need the release angle to shoot something, and now there's a lot of stuff to be changed here.
You can see it on the top left what you can change.
Yeah.
So all the variables you have.
So there are 4 others that we can also change, and maybe a combination of those 4 others gives us the best quality class. And what methodology from our training would now be the best way to do with the least amount of work, find the optimal combination of those other 4 factors to be sure that we are able to beat Kjeld, if that's possible. What kind of method would we use to do that? Anybody?
Design of experiments?
Exactly. Thank you, sir. Exactly. That's exactly where we're working towards, right? So that would be the absolute mathematically best way to play around with this online catapult. Absolutely least amount of playing around to get to the best combination of all these other factors to beat Kjeld's quality class. Yeah. So obviously for you guys, the task now is not to immediately start a new DOE, just use one factor on one other level, just as a trial and error to see if your setting is able to beat Kjeld. Yeah. If you want to go for the black belt track, and if you want to spend, let's say, half a day this weekend, maybe it's raining on Sunday, then you could set up a complete DOE using this online model. If you want to go for the black belt trap and don't want to spend your Sunday, absolutely no problem. Even more useful to do it next week on your own physical catapult, because that's the decisive thing, to find the optimal settings there to get to the best possible quality class.